iPhone here, and I'm back with another video, and today we're going to talk about DFS Coerce. DFS Coerce, another one of the NTLM reflectivity attack types, this one using distributed file system. So how bad is this? How bad are these attacks in general? What can we escalate to? I'm going to show that. So we're going to use DFS Coerce, and we're going to take a user that is basically a standard user, and we're going to escalate all the way to complete full level domain compromise. We'll get all the way to the Kerberos ticket granting ticket account. We'll get the hash from that. So let's go ahead and start. I want to start, we're going to use NTLM Relay X, then we're going to use DFS Coerce. So let's start with NTLM Relay X. I'm going to paste these commands in because they're quite long. So we'll start in our PKINet tools directory over here because we're going to use this PKINet tools to escalate further, but we'll paste in our NTLM Relay X. So we start with Impacket NTLM Relay X. Then we're going to use HTTP. This is the HTTP directory of our certificate services. And then this is our SMB2 support and ADCS. This tells it to use Active Directory Certificate Services. And then we're going to register a template of domain controller. So let's go ahead and we'll start NTLM Relay X. Okay, and if I can type the password right, it should start. And there we go. There is NTLM Relay X. So it is now waiting for NTLM hashes to come back to me, relay them on to the certificate authority. So the next step we want to do is DFS Coerce. So DFS Coerce, we're going to use our user Clint Barton here. And Clint is 0 permissions in the Active Directory. He's just a standard domain user. So I'll come over here to HackLab DC and we'll find Clint just to verify. Here's Clint Barton, and he is a member of domain users, not a member of anything else. So we're going to use him to take over the entire Active Directory. We have an account password that works for him. We've stolen that by password spraying or some other method, but we're going to escalate all the way up. So let's go back over to our Kali box here, and we will start DFS Coerce using Clint's account. And then we will go ahead and just relay. And then notice it says error bad net path, but it also says sending and net DFS remove standard route successfully bound. So that means when we come back over here to NTLM Relay X, we're going to have a certificate. So we now have a certificate of the machine account of a domain controller. That's what the $ means. So that lab DC, that is our domain controller. And I now have a certificate issued to me that is the base 64 hash of a certificate that can be used to be the domain controller. So we're going to do some changes to this, mess around with it, and then we're going to log in with this certificate. So I'm going to go ahead and get all of this info on the screen here. We'll just copy this, copy selection, clear the screen, and then we'll go VI cert.text. Just like that. We'll paste this in. And we have our certificate in a text. Go ahead and escape. And right quit. And there we go. Now when we cat cert.text, we have the certificate. So now we need to unbase 64 this cert. So let's do this. We'll clear screen one more time. We're going to go cat cert.text. And then we're going to take this pipe to base 64-D. And then we're going to create certificate.pfx. So we're creating a PFX file from the unbase 64 certificate that we received. So there we go. Now we should be able to, that looks a little strange. We should be able to use the certificate PFX to then authenticate to the domain controller. So we're going to use a tool called gettgt pkinet.py. That is part of the pkinet tools here. And we're going to create a file called outcccache. So what I'm doing now is I'm using this certificate that I created. And I am going to authenticate to the domain controller and get the ticket granting ticket. Now the ticket granting ticket is a very special ticket. The ticket granting ticket is the passport stamper It's the one that says you can go anywhere. It's the not a ticket, it is the granting ticket. So I'm now granting myself basically access to everything. So let's go ahead, we will run this. And notice we now have a TGT. It says requesting TGT and saved TGT to file. So I have a ticket granting ticket. Not a ticket, not a Kerberos ticket, the ticket granting ticket. That's significant. So my final step here is I'm going to take this and I'm going to do an attack called DCSync. DCSync is a very famous attack. It was originally part of Mimikatz, but what it does is allow me to get the hashes of everything in Active Directory remotely. At this point, I fully impersonated a domain controller. So now I'm going to tell the Active Directory, hey, I'm a domain controller too, replicate everything to me. So let's go ahead and do that. And here we're going to just use our typical secrets dump. So we created an out.ccache file. And if we cat out.ccache, you can see this is a Caribou TGT, right? It doesn't look great, but it does say Caribou TGT right here. So let's clear this one more time. And I will now paste in my clipboard. And then we have our out.ccache file that we are feeding into secrets dump. And we're just going to do a debug, no pass. And then this is the account, the machine account of the domain controller. And then we're going to output a file called DC secrets dump with all the different secrets. So here we go. We'll go ahead and run this. And then down comes all the hashes. This is all of the hashes for the entirety of Active Directory. But I'm really interested in one. I want the hash of the KRB TGT account, because the hash of the KRB TGT account means that I can create a golden ticket. And a golden ticket can allow me to persist in an Active Directory for roughly about 10 years if the organization isn't changing the hash of the KRB TGT account. Now, I definitely recommend you change the hash of the KRB TGT account. I would say do it as frequently as monthly. But just realize to invalidate a golden ticket, you have to change it 2 times. So you have to change it once, then let Active Directory sync, and then change it again. Now, Microsoft says you should wait about 10 hours between. I've seen it faster in some organizations and slower in others. But changing that KRB TGT account, very important if you want to invalidate golden tickets. So if you ever have a DCSync attack happen in your environment, make sure you're changing the password of all of the domain admins and the KRB TGT account. You can initiate a full domain password reset. I don't always recommend you do that, but just realize that all of your hashes have been stolen at that point, every possible detail. Okay, so we've got a bunch of hashes here. We'll go ahead and clear this out. And then we're just going to cat our DC secrets dump NTDS file. We're going to grep out KRB TGT. And there we go. I have my hash for the KRB TGT account, which means I have full persistence in the Active Directory for up to 10 years if you're not resetting that KRB TGT account. So that's how easy and how damaging DFS Coerce can be at its worst. But we can detect this. And we can detect this attack in multiple different ways. Now, we can't detect DFS Coerce itself's usage, but we can detect the pieces that would come before and after. So let's take a look at our Elastic SIEM over here. And we'll start with our discovery. We'll go out of the rules for now. And we're going to look for event code 4688 to start. Actually, that's wrong. 4886, excuse me. I mistyped that earlier. Event code 4886. And event code 4886 is a certificate issuance. So if your certificate authority is set up correctly and logging correctly, you will get a 4886 every time a new certificate is issued. Now, a certificate being issued for your domain controller, like we're looking at right here, isn't great. This shouldn't happen often. Notice we're seeing the HackLab DC2 domain controller certificate template, and the certificate authority. This should not happen often. And as a matter of fact, you should be alerted from your SIEM when it does happen. So we've created a rule for that. And I'll show you that here in just a minute, but I want to show you some other things that we can detect. So we can also detect the DCSync attack. So if we go 4662, we can detect the DCSync attack from the network perspective, or not from the network, from the system perspective, and that one's not it. These logs happen quite frequently, so we may have to dig a little bit here back in time. Very frequently. All right, so we're probably better off actually looking at the rule query for that one because it's too long for me to paste in. But we'll look at one more before we go further. We'll just do event code 4768. And this is the login to a system by a certificate. So if your environment uses certificates for login, then that's fine. This would be normal, but most environments do not. And as you can see here in our certificate information, we're showing a login via the domain machine account, DC machine account, with a certificate. That's extremely abnormal, right? This is a good alert for these types of attacks happening. You really should be using stuff like this to detect these type of NTLM relay and certificate attacks. This implies that I stole a certificate. I then logged in as the domain controller's machine account to it and said, hey, do something, right? Not common. So, all right, let's go take a look at the rules we've created. We'll go over here and we'll go to alerts. And we should have a whole bunch of alerts that we just hit. And notice we've got 5 of them that we hit from our attack right there. And this is how it should be in your environment. If you are being the victim of these style attacks, you should have just a slew of alerts hit all at once. So notice we have our DCSync event log rule. And if we look over here, we can see that we have a count of 570 DCSync event logs that match that event that we looked at a minute ago. That 4662, excuse me. So if we view all fields in the table here, we can then see the DCSync events as they happened. We should be able to see, let me find it here. Now let's just pull in the rule alert. But regardless, let's see here. If we investigate in timeline, this will give us what our rule is. Event code 4662 and winlog event data properties with this particular string. And then an access mask of 0x100. This is not the Sigma rule. If you use the Sigma rule, you're going to miss things. This is a handcrafted rule because the Sigma rule is looking for it not to be a machine account. Well, I just used a machine account for DCSync. So be careful here. Make sure that you're not excluding your machine accounts. Now, if you don't exclude your machine accounts, this may be loud. So what you want to do is exclude domain controllers from this. But you can, anything that got that $sign of a domain controller syncing down, you want to make sure that you're seeing that. So if we look at one of these events, you can see here's the log message with the key, the 1131. And here's the SID, and here is the lab DC. Now, one of these events will happen for every account that is synced down. So if you have 500 accounts in your environment, make sure you're building a threshold rule here or you will bury yourself. You want to have threshold on this particular one. So let's go back. We'll take a look at the syntax of our rule just to make sure everybody is on the same page here. DCSync event log rule, event code 4662, and winlog event data properties, and winlog event data access mask 0x100. This is a threshold rule I've configured 50 unique values happening within the period of time that we set for the rule, which is 1 minute. So if you see 50 of these in 1 minute, this is going to fire. Now, this is not the most accurate way to detect DCSync, but it can give you an advantage if you don't have network-based detection. So let's take a look at the network-based detection way of catching this. You come over here to rules. I have DCSync IPS rule fired multiple times. And what this is I have Suricata running in this environment. Now on Suricata, if we go over here to our Discover, and I search in FileBeat, and I search for my rule here. Oh, let me take the E. I search for rule name, anything that has the term DCSync in it. And I come over here and notice I'm going to have a whole bunch, 4,856, because I've done this attack a couple times in a real short period of time. But if I look at this rule, what it is, it's a snort rule. And I'm detecting the usage of the DRS UAPI within snort. So if I come over here to my network intrusion detection system and I cat out my custom rules here in Suricata, you can see I've got a whole bunch of rules that are DCSync and DCShadow. DCSync, I'm using the DRS UAPI. I have flow established, and I'm looking for content of this. I'm a depth of 100, and I've set the flow bit set of DRS UAPI. And what I'm seeing is I'm doing dsget NC changes. This is, hey, give me all of my account changes, right? So this is a very, very accurate way of detecting a DCSync attack, and the best way. It's much easier and much more reliable than the event log method. These rules, they're originally written by Didier Stevens. I kind of changed them just a little bit just to make them a little bit more accurate, but I can give you a link in the video notes to the original rules from NVISO by Didier. All right, so we've caught the DCSync 2 ways. Let's see what else we can catch. So if we go back into our rules over here, back into our alerts and see what else we caught. Oh, I chose the wrong thing. Security alerts, not overview. We should catch the usage of the machine account login via certificate. We'll also catch the issuance of a domain controller certificate. So let's go in order of what we did. So we got a domain controller certificate issued to us. So if I pop this open right here, we'll open it in a timeline, and then we'll open this. And in here we can see we have a domain controller certificate issued. A certificate was granted to a domain controller by a user. That's the description of the rule. This is event code 4886. And it comes from our certificate services logs. So if we jump over here to HackLab member, you can see 4886, and this shows that it is generating a certificate to the DC. This should almost never happen. Almost never. How often do your domain controllers get new certificates? Super rare. And yeah, I want a SIM alert when that happens. Now, this is off by default. You have to come into your certificate authority, and then you have to go into properties and auditing, and you have to turn on events to audit here. If you don't turn this on, you will never get these alerts. So make sure you have these turned on. And CAs are becoming such a target by red teamers and attackers that I would definitely be logging this stuff. All right, so back to our SIM. We detected the issuance of a certificate of the domain controller. Now, if we detect the machine account login of that particular domain controller, and let me choose timeline view, we have basically detected the entirety of the attack. So let's just take a look at this. And we should be able to see a machine account is logging in via certificate. We can also see The event code, our query is 4768, and win event log cert issuer name and win log data target name $. So that means that a machine account logged into the network via a certificate. That's extremely rare. Should never happen. So we've detected several different pieces of the attack now. We've detected 5 different detections from that attack. Now this is a complete takeover. So I'd expect you to have 5 SIM rolls fire. Now how do we stop this attack? It's very simple to stop this. This is actually the simplest part. Building the rules, doing the attacks is even harder than it is to stop this. So we jump over to our certificate authority over here, and we open IIS. You literally can go to cert enroll and cert serve and go into Windows Authentication here, choose providers, and then remove NTLM. I would put Kerberos in here and make it only Kerberos. Or the certificate authority especially. So cert enroll and cert serve, I would make sure that there is no NTLM authentication anywhere near this. And that stops this, because the initial certificate grant, if you have auto grant, I have to go through this method to make this certificate come to me, which enables the entirety of the attack. I can't do very much with the NTLM hash of a domain controller versus a certificate of the domain controller. I still can do some stuff with the hash of the machine account of the domain controller. Right? I might be able to get a DCSync that way. But DFS Coerce typically is using this method. And most of the NTLM reflectivity attacks use this particular method. They don't use the hash from the domain controller that could be reflected. You can still reflect it. But I would definitely take this step. This is extremely important. And that's all I have for this video. If you like these, please comment, subscribe, and let me know what you want to see. Thank you.